Cool, thanks. What I want to talk about tonight is a little project that I started working on because I dislike most metric collection software out there, Collectd, Munin, all those guys. So I started something called Shh, because every time somebody would come up to me and we'd start talking about it, they'd go, what about Collectd? And I go, shh. Anyway, I am Edward Muller, as Joe said. Here's my Twitter handle, my blog, which is just imported from Posterous into a Jekyll, so it looks like crap. So, styling would be awesome. I work at Heroku. What is SHH? This is System Heuristics Herald. It does pretty much what all those things, all these types of things do, like Collectd and all those guys. It pulls system metrics and sends them somewhere. It's hosted on GitHub, just because, where the hell else would you do it these days? Oh wait, Atlassian. Sorry. Yes, it is a backronym. We had to come up with it because people kept on going, what does it mean? And the previous discussion about shh was just way too complex for most people. So my goal was that I wanted to use the same set of metric paths for applications as well as systems at Heroku. Most applications on Heroku have this path. An app emits logs. The log metrics are formatted in a very particular way. They go through a system called Logplex, and I'll send around links to this. This is just a gist. It has links to all these different little pieces of software that are open source. The logs go to Logplex, which is basically our log routing system at Heroku. If you've ever done Heroku drains add or Heroku logs tail, you've interacted with Logplex. They go to something called L2met then, which actually does a drain, and L2met converts them into something that then sends them to Librato. But note, anything can drain from Logplex, so once you get your data into Logplex, pretty much anybody can listen for whatever they care about listening to. This is what the old system metric path looked like. Collectd, a write HTTP plugin. There's some logic in there to make sure Collectd and write HTTP is actually working, because depending on the version of Collectd you're using, it would actually just die and stop submitting metrics. To something called Backstop, which is a web service that was written that converts these HTTP puts or posts into either Carbon or Librato metrics, one of the two. So this is what the new system metrics path looks like for a small subset of our apps. SHH, or sh, generates logs, which go to Logplex, which then L2met drains, and they go to Librato. You notice what's the same here? I mean, it's the same exact path. So I consider that a win. I'm actually going to start at the bottom. If you're not familiar with 12-factor, the whole idea of logs and everything as structured data is part of the 12-factor system, which Adam Wiggins, who's our CTO, talks a lot about. There's 12 bits of pieces in there, 12 important ideals for developing an app. One of them is logs. One of the other ones, I'll get to some of the other ones later. But for us, there's no difference then between what an app is and a system as far as how metrics get delivered. There's less cognitive overhead in that whole process when trying to talk to somebody who 90% of the time all they care about is working on the app that runs on a system which my group provides them. We're not running Collectd anymore. If you've ever had to package up Collectd, like for custom reasons or anything like that, you might want to punch it in the face. I have in the past. If you've ever had to write a plugin for it, which I have in the past, I don't know. Individual experience may vary, but it wasn't a fun experience for me. We can retire backstops. There's one less piece of software in production as well. It means one less thing that my group has to maintain and care about, things like that. Previously we had splits between Graphite and Librato, and the idea, at least for now, is to move everything to Librato, put all of our stuff there. There's one authoritative source for all of our metric data. And in the end, no more graphite to maintain too. Once that's complete, then no more graphite, which is another thing that our group would end up having to maintain and scale out individually as necessary. And we have enough to do. We have lots of clouds to interact with. We have lots of things to scale. I don't really want to have to worry also about scaling graphite. So I kind of alluded to some of this earlier, but why not collect D or munin or anything like that? Initially, I really just wanted to learn Go. So SHH or sh is written in Go. Go is Google's one of Google's newish languages. And I also don't like most of the existing systems out there. They're antiquated or hard to manage, and you can read, so I won't read. Some additional considerations when I started writing SHH is that I dislike purpose-built config files. If you've ever messed with Apache or collectd, those config files can be annoying. I don't like them. SHH uses environment variables only, which is another pillar of the 12-factor app design process. These are usually, I encode these with mdir because, mdir just makes that easier. And there's a link to mdir if you don't know what that means. So how does SHH work? It pretty much works like most of these guys do. There's a main loop, it ticks. It tells all the pollers that either by the default config includes or the ones you've set via an environment variable to poll every interval. And then these guys feed individual measurements onto a Go channel, and then an outputter basically decides what to do with the measurements it gets off that channel. So measurements are pretty simple. This is a little bit of Go code taken directly from SHH. When the polar represented as a string, basically a slice of strings is what is being measured at that given time, and then the value. And you'll notice the value is not an int or a float or anything like that. It's an interface. So we can be a little bit flexible with that. Right now, Relay only support floats and ints in the system, though. Well, actually, unsigned ints and floats. Polars, these are the things that generate measurements. And I use Go's interfaces. So basically, anything that implements these three methods in Go can be a polar. There is a list of the current polars that I wrote. These are your standard stuff that you'll find, disk IO, disk free, load, NTP skew and stuff like that, whatnot. The outputter interface is pretty simple. It has a start. I actually need to revisit this interface, but you tell it to start, and there's a method that takes a channel, and that's it. That actually should be part of the interface, hence the part I need to refactor. Mind you, also this has had dozens of hours of work where things like munin and collectd and all those bits have had hundreds and tens or hundreds of thousands of hours worth of work put into them. These are the current outputters. Standard out raw, which uses our metric log format, but it just sends out the raw values that it receives from the measurements. There's standard out derivatives, which will, if there is it'll convert things that are counters in classic R or D type style, ever increasing values. It'll write out the derivative for them, i.e. the time and the change during that period. And Librato, there's a direct to Librato one. So integers are counters, floats are gauges, but that is dependent on which one of these you choose. If you use the Librato outputter, it does the same thing. It submits anything that's an integer as a counter, anything that's a float as a gauge. So brief demo. This is a line note I have. Oops, I can't type. So, it's running. It's running. I have it running via Upstart. Let me actually kill that. And then I can do Actually, this will, yeah, so this is going to send directly to Librado. The default is not to go to Librado, just to standard out. So I will just do this. And this is the default format. It's going to now poll every little bit. So every, I think, 20 seconds, the default interval that's specified, you'll just get a wash of information. You'll see that, I mean, like if these values are changing on the system, they'll obviously be different. This is my personal line node, so it doesn't really matter. But I also made some, whoops. I threw together a little dashboard earlier before I came. These are some of the values, obviously, that you can then chart on them. Your standard fare of metrics. There are though many metrics that I don't have in any of these things. So if I look through this list, I mean, these are basically all the default metrics that the existing pollers can generate. And I'm waiting for the loading to go. Yeah. There's a lot of NTP date ones because I think my line node is set up with like 10 pool servers, and then it generates a whole bunch of metrics for each server that it contacts. So that's why you've got NTP date delay and skew and everything else like that for all these different guys. Anyway, you get the general idea. There's a lot there. Let's see. So problems that I've so far discovered, I'm sure there'll be plenty more as I continue down this path. It goes a little bit newish. It is a little bit of, it has a VM to it. 1.1 should be out sometime this year. Fix a bunch of issues. Not that I've really run into any. I've noticed on the systems that I run it on, compiling with the current Go, it's vert, which is important for our Postgres team. Memory usage is in line, if not lower than collectees, although its RSS is a little bit more. I also may be overusing channels, which is leading to a bunch of extra GC runs, because Go does use a VM. So CPU time is a little bit higher, but not horribly so. I'm taking naive approaches to many pollers in these cases, where sometimes just reading some proc files when a syscall will be a heck of a lot lighter, because the syscall is actually just doing, the reading from the proc file is doing the same work as the syscall, except I have to go through a whole bunch of extra interface to get there. My target's Linux only at the moment, because our group gives Linux systems and makes tooling around Linux systems for other people at Heroku to then consume and run their apps on. And whatever else I haven't run into yet. For the future, though, internally, we've got already slated some more pollers to be written. I personally want to write some more outputters. I would actually like an outputter to go to Carbon, to Riemann. There's another clustered metrics collection system I ran into, OpenTSDB, that I'd like to write an outputter for. I'm also looking for more people to adopt it, obviously, and hence talks like this. Hopefully I can find some other people that are interested in it. Questions?
Pull requests welcome?
Oh yeah, pull requests are always welcome. It is open source. I've temporarily attached the GNU license to it. I don't know if that'll be detrimental or not, but I'm open to GPL v3. But I am open to revisit that if that is determined to be a problem. I'd like the viral nature of it, because if I give you the stuff that I work on, I hope you give back. And that's not always true in lots of other licenses. But yeah, we are rolling it out slowly at Heroku. All of our API instances and a whole bunch of other ones already use it. So it's in use in production already.
So part of the benefit of using Go is that there's very few external system dependencies, right?
Yes. So Go, when you compile your code in Go, you basically get a static binary when you're done, which then it's pretty easy to copy out to other systems. So if you compile it on a x86 64 system Linux, you then have a binary you can literally copy to pretty much any Linux system as long as the kernel interface really doesn't change.
Yeah, I mean, another issue like we've seen with users that collect these, like on CentOS, it ships with a version of Python that's so old it's broken for a bunch of the collectee plugins. So.
Yeah, and that gets back to the whole custom packaging thing with collectee for me. You were next.
Yeah, this is an unfair question to ask, but I'm just curious. Because we've done this actually. We basically have an agent that parses collectee packets and then pushes them out into our own system. And so I'm kind of curious, like, how you feel about this shaping out. Because in my mind, what you want is something that's kind of all things to all people, right? So the richness of what the collectee plugins offer right now is such that just to get the kind of all those like crazy MySQL or virtual memory plugins or things that people might want to turn on, you want to enable that on that side. And on the other side, you want to enable things like StatsD protocol, and like you talked about OpenTSD. Is that something that you guys, it doesn't sound like that's something that really lines up with your own roadmap, though.
Well, I separate those two into pollers and outputters. So if you can either write one in Go for any of those things. I listed somewhere in there a listen poller, which is a simple plugin interface. Basically, you said, SHH, go listen on this port, which could be a Unix socket, it could be a TCP port, it could be a UDP port, and then get metrics in that same format that you saw, and then just do whatever you are doing with all your other metrics. Just whatever that means in that particular configuration. So I hope to take a look at maybe integrating with some of the other plugins that some people have written for collectee and stuff like that, because its format for most of the collectee plugins is collectee runs these things for a long time as a sub-process, and then they have their own intervals and they do whatever they want to do while they're doing that. So I feel that there's some adaptation there for some of those things, for some of the extra ones.
Exec plugin?
Yeah, the exec plugin.
Okay.
I mean, that is one of the ways to write a plugin for collectee. You can write it in C, exec. There's Python, Ruby, plugins, Perl, et cetera, et cetera. But so I don't know if that answered the question or not. I wasn't quite sure what it was.
So I'm just trying to get at like where that could go. Like you could kind of go that path in terms of building it out. I don't think that's really in line with Heroku. Or you could even go a path where like this becomes a little bit more like StatsD, right? Where you can take in timers and this thing can actually figure out percentiles and things like that, and then you can let down.
Yeah, I think
I didn't know which way is more interesting to you.
my goal is to get system metrics out of the system into, like my core goal is to get system metrics out of the system in the same format and pipeline that apps use, so that there's it's just less cognitive overhead, less stuff for me to maintain as well, less stuff I have to teach people.
And for you guys, that's logs, right? So
For us that is logs, hence standard out. We just literally, the deploy at Heroku is pipe this to logger, pipe the output of either standard out raw outputter or standard out derivative outputter to logger, and let the logging infrastructure deal with the transport. Because we have extensive stuff that some data goes into Splunk, all data goes into Logplex, et cetera, throughout the system.
Oh, two things. One is, it seems that there's a somewhat of an overlap between this and some of the system configuration tools like CFNGen, SaltStack.
In what way? I'm curious because
those can collect the data and then send it off to the pipeline.
Okay, because we use Chef to deploy this, and that's another configuration system.
Files that it can just collect, and with SaltStack, you have the ability to do something similar for
Okay. I've never actually looked at SaltStack, although it's come on my radar as of like a few weeks ago or something.
I feel like using mcollective to pull data, same kind of.
Yep. Yeah. There's many things that do all of this stuff already. I'm not blazing a new trail here aside from like scratching my own itch.
The interesting thing that you might get from SaltStack that you might be able to plug into this is they use a 0MQ as their transport mechanism.
Okay. Well, yeah, there's certainly nothing stopping somebody from writing a 0MQ outputter or even a 0MQ poller to do the right thing. And the listen poller is a good example of a process or a Go routine basically in this that just starts off and listens on the background and interacts with the rest of the system. So it can plug in on both ends relatively easily, as long as there are, in this case, Go bindings for 0MQ, which honestly I haven't looked at.
And the other part is, the other experiment I was looking at, Akamai, they actually built a SQLite engine into every kernel.
That doesn't surprise me.
So that you query the system to collect data through SQL.
Oh God. Interesting.
Is it in a state where you can actually write plugins that are outside of the Go language, so that if you have existing plugins that you just want to tie in, you didn't really want to run the listen interface for them, you know?
Yeah. Well, you would use the, let me show you what's at the top of the listen file real quick.
It sort of seems to me like, you know, Sensu and
Here,
TSDB and all these things are trying to build their own thing.
Yep. Sorry, yeah, yep. All right, it's cut off a little bit, but you get the idea. This is the listen interface.
It's impossible to read that.
It is? Oh, maybe I'll unhighlight it.
It might actually be better. There you go.
That work?
Yep.
I mean, this is a way. This is a plugin written in pure Bash. Yeah. Actually, I'm missing the netcat. Damn. Yeah. Basically, you. Oh, it's. Oh no, you're right. It's there. If you go to the right. There you go. Sorry. Yay.
So you could execute any executable command from Bash.
Yeah, it gives you a local Unix socket to talk to, you know, TCP or Unix socket, your configuration choice really. So as long as you write something that goes to that format, which most of these extra ones are easily mutatable because they're either written in Python or Bash or Ruby or something like that, it should be relatively trivial to change them to this format. And again, it's a very basic date. It's a pretty basic date what value format.
So I have a question. I'm trying to frame this in my mind. On one level, I'm just seeing repeating the wheel another time here. What was your motivation for starting this again?
The original motivation, like the core, was I was home on a weekend and my kids were at the park and I had some free time and I wanted to learn Go. I wanted to actually write something in Go that I would use, and I dislike, for reasons that I've probably talked about, all the existing solutions out there for various reasons. They're not bad. I've used them. I mean, I do DevOps for a living, so you know, I've used my fair share of them.
That's fair. We all want to learn something. Now, what is the major benefit of this over some of the other things that you have?
So we took a look at Collectee, and we basically said, so who wants to write a plugin? And no one raised their hand. Who wants to maintain the plugin? No one raised, who wants to do this? Well, no one raised their hand. Who wants to switch to something? Who wants to look at all the other alternatives out there? And no one raised their hand. So basically, you know, it was like, well, Ed's got this thing he's been playing with. And I'm like, I think it fits all of our needs, and I'd be happy to write other plugins for it. You know, as you know, if any team needs some metrics gathered, I can do that. We have the technology. So, yeah.
So is there a significant resource save in some cut through this?
I'm not maintaining Collectee packages, which we have some in our private Ubuntu repo. Eventually, I won't be, because I live in a dual world right now where I've got some systems running this and some systems running Collectee.
I mean, with Collectee, you would have had to have gotten all of the existing plugins to talk the L2MET log protocol, right?
I could have written a plugin that worked like their network plugin that would just listen to all of the metrics internally. Collectee is actually kind of structured in a very similar way internally, so that you can register to get all the stuff as well as send the stuff to it. Go just makes it really explicit with channels and Go routines and things like that. It's also cognitive overhead as far as writing these things. Let me see if I can show you an example. The listen one's a little complex per se, but let's see. Load, there you go. I mean, that's the load plugin. It opens something, reads some data from the file, closes it, creates a little buffer, reads the string from it, splits it basically. This is a split in Go, submits the measurements, and that's it. I mean, I took a look at, again, this is very Linux specific. It doesn't do everything that the collectd one does for load, but the collectd one is not that small.
So the final question I'm going to ask is, Heroku is really an application-driven company with something underneath.
Yep, I work on that part.
You're in the underneath part.
Yep.
How does this intersect with the metrics from the point of view of the application as opposed to the infrastructure?
Can you go back to your dashboard that might?
Actually, in the case of that question, probably not at all. Because this is on the components underneath everything that a user of the platform would see. We don't really give disk space. It's all transient. But like the people who run our runtime systems, which is where your dynos run, right? They can use. We have some similar dashboards like this, based off SHH data. That shows them some key metrics, and they can dial in a particular system, and there's some high-level ones as well, and they can use it to troubleshoot problems and stuff like that. I mean, they could do that with anything that generates the graphs. It's just that app-wise, for all the applications that run on those runtimes that execute the dynos, they submit all of their metrics through that whole stream that I showed earlier, and they end up in Librado, right? But previously, the engineer would have to pull up a separate dashboard, a graphite-based dashboard, and go look for all the system metrics there. Now, of course, I could do other things, crazy things to merge those two, but I just want to get all the data into the same flow and format that the guy who's writing the system that manages the dynos already uses. Cool. Thanks.